Hello guys, welcome to a new video from my YouTube channel about Komin. In this video we are going to give you an introduction about Komins and I am Hesam Kuchek. Let's see the contents in this video. First of all, we give a brief about Komins, then we see the advantages and disadvantages about Komins. After that we see some applications and uh, actually before that we see how comments actually work. Let's start the brief. Uh, Comments is an uh, artificial intelligence algorithm used to cluster our data. Uh, it means when we have some unlabeled data, we apply the Cummins algorithm on those data, and we can have some clusters uh, on that data. We further see more about this. Cummins actually divides data into core groups, and that core represents that the count of groups we are going to have after the algorithm done its uh, process. One note in Cummins that should be noted is that core should be chosen carefully because if that car doesn't fit on our data, it can cause some problems as malformed uh, cluster selection or some problems like that. So car should be uh, carefully chosen. And these are two images about how comments actually look like after running the algorithm. Here, if you can see, we have three groups. First of all, on the raw data, we don't have these colored groups. All of these data are the same color, and after we apply the common algorithm on this data, we can have this colored and comments. Actually here is set as 3, and after running we can have 3 groups on green, red and blue. And here also we can see in a three-dimensional space which we easily reach to 3 groups of data. Now let's see the advantages of the Cummins algorithm. Cummins is an easy algorithm that can be easily implemented. Uh, it's very fast and scalable. It means on the new data we can fastly run the algorithm, and it also categorized the new data, and it has lots of application in the industry, in the research studies and other kind of stuff. Some disadvantages of comments are uh, it necessitates us to uh, carefully select the value of the car. Uh, in the uh, image we have seen here, we mentioned that here car is set to 3. Okay, so it greatly fit onto the data. But if we have chose the um, for example car to the number of 4, the clusters here would be malformed and completely uh, actually not fitted onto data. So we need to carefully uh, choose the value of car, and if we will not, we can result in bad clusters. So we need to put a lot of attention in the selection of the value of car. Also, it needs seed selection, and we further discussed about what is the seed selection and how does it works. But here, just as an introduction, we need to uh, state that seed selection is something that how groups are going to shaped and how the algorithm would start at the 0 point. Also, Cummings is very sensitive to outliers because it works with the mean of the data and groups, and actually it selects car uh, mean points and then try to fit and correct that mean point. So it is really sensitive to outliers, and we need to be aware of this flaw, and sometimes we need to dismiss the outliers. Um, After that, Cummings has lots of struggles with high dimensional uh, data sets. It means some datasets have lots of features, and it means they are high dimensional datasets. And Cummings um, really struggle with those kinds of um, datasets because it needs to calculate lots of features. Now let's see how Cummings work. First of all, Cummings uh, chooses a centroid for each cluster. It means randomly at the 0 point, Cummings randomly chooses car centroids, and after that try to figure out the best location for those centroids. Uh, After choosing a car randomly chosen centroid, it tries to assign each data point to the nearest centroid. It means it actually tell each data points is related to which of those centroids. After that, Cummings calculate the mean of all data points, and uh, after that moves the centroid to the mean, and we can see it further. After that, uh, Cummings just repeats uh, until two conditions are fulfilled. First condition is that no more moves is actually performed. It means the mean is actually the location of that centroid. Or at the second condition, we can set a maximum number of movements and calculation, and after that maximum number, if it's reached to that maximum number, it means we stop the algorithm and won't go further. And this is an example. We have raw data given to the algorithm. At the first comment, just select two centroids. We set the call to 2 and just randomly select 2 points. After that, a comment try to assign each data point to the nearest um, centroid, and here we can see that reds are nearest to this and blue ones are near to this centroid. After that, we calculate the mean of these blue and red points separately and just move the centroid location to that mean location. After that, we again assign each um, data points to the nearest answer. For example, if here they are red, but near to blue one, we just change the color of this red and assign the color of blue, which this image results. After that, we again calculate the mean. So here is the mean of two groups, and here we can see the groups are well separated, and somehow if we calculate the new mean, it would be at the same position of this centroid. So we stop the algorithm and give the output with these two groups and centroids. And now let's see some of the applications of the Comin. Uh, Customer segmentation is one of the application of Comin. It means, for example, we have a bank, for example, and we want to see which of the customers are loyal, which of the customers are not loyal, and use those data and prediction about giving a loan, for example, for to some customers, or giving them some special offers. The next item is document or social media clustering. If you use social medias, you can see that if you like some posts, you will be shown similar posts in the future, and this action kind of fulfilled using clustering, probably with comments. After that, we can see image segmentation. Image segmentation is used in computer vision, and by that we can segment images into several segmentation and process them using computer vision algorithm or artificial intelligence. The last item is cybersecurity and anomaly detection. Anomaly means something that is odd in the system. For example, if you are a customer of a bank and you mostly deposit $10 per day, and one day suddenly you deposit or even withdraw lot more than your daily routine. For example, you always withdraw $10 per day, but one day you suddenly withdraw $100. So that's an anomaly, and the bank should announce you and give you a notification about this anomaly to check if you uh, are the person doing that transaction. Thank you for your attention. I hope you found it useful. Goodbye.